So today we're going to be continuing equivalent ratios. So we're working again on ratios. And today our I can statement is, I can develop an understanding of equivalent ratios by using tape diagrams. Your lesson is going to be on the active board in a video format where you're going to be answering questions for Socrative, just since I didn't know who the substitute was. So let's look at our I can statement. I can develop an understanding of equivalent ratios by using tape diagrams. Well, yesterday we found out what a ratio was. That's when we are comparing two things. So here would be an example of we're comparing 5 girls to 15 boys. Remember, we can write ratios with a little semicolon, with that word to, or we can write them as a fraction. So what's different about today's I can statement is this word, equivalent. What does equivalent mean? Well, equivalent means that they are equal. So that base word in equivalent is equal. What's the other word that we have? Well, it's this tape diagram. So tape diagram, remember, is what we use to make models. So tape diagram is when we have rectangles that represent numbers. We use them in expressions. Now we're going to be using them in our ratios. So this would be an example of a tape diagram, when we have these rectangles that represent numbers. So this would represent 2. This would represent 1. So let's go on to our next problem. We're going to watch a short video on mixing paint. So here our video was on the emphasis of ratios need to be the correct order. He did a ratio of 5 white to 1 red, and it became pink, when what his Nana really needed was 5 red to 1 white, and it should be a darker red color. But since Grandma flipped the order around, he had the wrong color there. So we're going to review what we did. So with a partner, you're going to write a sentence story problem that involves a ratio. So remember, this A means 1. So you're writing a 1-sentence story problem that involves a ratio. Then you're going to write that ratio 2 other ways. So here's an example of what we're looking for. The ratio of the number of sunny days to rainy days is 12 to 1. There's my sentence. And then the second part of these directions was write a ratio 2 other ways. So here's my first way, here's way one, other one, and my second other way. You have till the timer runs out. Please do this on your notes. So please write these on your notes. Okay, you're at 45 seconds. You're at 20 seconds. All right, pencils down, eyes up at the active board. Right underneath your sentence and your other ways to write ratios, you're going to copy our I can statement and you're going to label it Lesson 3. So right underneath what you just wrote, you're going to write Lesson 3, equivalent ratios, and our I can statement. Please do that now. You have 15 seconds to finish copying. Alright, so now we're going to start today's lesson. We did a review of that ratio writing, so now we're going on to something different. Okay, you're going to hear a story problem. You're not going to be able to read the problem. So what I want you to do is I want you to think of what's the key information in this story. You're going to listen to it twice.
Karina and Japsiri are using ribbon to decorate a project in our class. The ratio of the length of Karina's ribbon to the length of Japsiri's ribbon is 7:3. Draw a tape diagram to represent this ratio.
Okay, listen to what's our key information, or what information do we need to probably solve this problem. We'll listen to it one more time.
Karina and Japsiri are using ribbon to decorate a project in our class. The ratio of the length of Karina's ribbon to the length of Japsiri's ribbon is 7:3. Draw a tape diagram to represent this ratio.
Okay, share with your partner, the person sitting next to you, what is some key information. You have 15 seconds. Okay, voice is off, eyes at the active board. Voice is off, eyes on the active board. Okay, one of the key informations you should have been who our people are and what they're doing. Here we have Karina, and it said 7. It said the ratio was 7. It didn't say inches, but I just put that there for a little help of what might it be talking about. Then it said, for another key part, Japsiri, and it said 3. Didn't say inches, didn't say 3 inches, but I put that there to help us understand what they might be doing. Then it also said that we're working with ratios, and it also said that we're going to draw something. So we're not going to write, we're not going to solve, we're going to draw. And our last one said, what is it that we're going to draw? we're going to draw a tape diagram. Okay, on Socrative, I would like you to select A, B, C, or D. What ratio described Karina's ribbon to Japsiri's ribbon? You have 10 seconds. What ratio described Karina's ribbon to Japsiri's ribbon? Okay, you should have all submitted an answer. Please look up at the active board. So our ratio was 7-3. It said Karina had 7 and Japsiri had 3 from that story. If we need to hear it again, here it is to verify.
Karina and Japsiri are using ribbon to decorate a project in our class. The ratio of the length of Karina's ribbon to the length of Japsiri's ribbon is 7-3. Draw a tape diagram to represent this ratio.
So we can make a table to organize our ratios as well. So here I have a ratio. I have Karina and her 7, Japsiri and her 3. And remember, I can keep doubling them or adding so much to each side or multiplying each side by the same amount. And they're all going to be equivalent ratios. But it was still asking me to do a tape diagram. So I still need to do that tape diagram. How can we accomplish that? Well, let's think. Karina has 7. So all I'm going to have is just 7 boxes. 1, 2, 3, 4, 5, 6, 7. This represents her 7 units of ribbon that she has. Japsiri has far less. She only has 3 units. So she has 1, 2, 3. That's all it's asking us to do is draw a tape diagram. Let's take it a step further though. Here's Karina and Japsiri's tape diagram again, but now we're going to have a different question. What does each box on the tape diagram represent? Well, it represents a unit, but we do not know what type of unit. We don't know if this box is an inch, or if it's supposed to be feet, or if they're all supposed to be yards. We don't know. The problem didn't say. If you remember at the very beginning of the problem when I listed them out, I put it was inches, but that was just so you knew that it did have some type of units. However, the problem didn't say, so that's what we're going to work on right now. So I want you to think, well, let's see if we can edit this. Alright, we're going to try it this way. What if each unit on the tape diagram represented 1 inch? What are the lengths of the ribbons? So each box is 1 inch. How much does Karina have? Think in your head. If you said she has 7, then you are correct. She would have 7 inches. Japsiri would have 3 inches. 1 inch, 2 inch, 3 inches. Let's try our next one. What if each unit on the tape diagram represents 2 meters? So instead of being 1 inch like our last example, this was 2 meters. This was 2 meters. What are the lengths of the ribbon? Well, it's going to be 14 for Karina. This would be another 2 meters, 2 meters, 2 meters, 2 meters, 2 meters. And I see that's 14 meters. 2, 4, 6, 8, 10, 12, 14. She has a lot of ribbon there. Japsiri, on the other hand, would only have 6 meters. So here I would have 6 meters. So let's think. What is the ratio of Karina's ribbon to Japsiri's ribbon? Well, look, I have 14 here and 6 here, so I could say Karina's ribbon is 14, 2 Japsiri's 6 meters. But if you remember, I also had from the previous problem, it said it was 7 to 3. And if I look here, I still have 7 boxes to 3 boxes. So which one is it? Well, guess what? We're not going to find out just yet. We still have one more problem before we discuss that. What if each unit represented 3 feet? What are the lengths of the ribbon? Well, Japsiri's is really easy. That would be 3 feet, 6 feet, 9 feet. So Japsiri would be 9 feet that she has. Karina would be 3 feet, 6 feet, 9 feet, 12, 15, 18, 21 feet. So that is how much each of them would have. Now let's look at question number 2. What is the ratio of Karina's ribbon to Japsiri's ribbon? Well, if I look up here, I have 21 feet and 9 feet, so I think it should be 21 to 9. But let's check our answer just to see if it's correct. Nope, I have this same problem. It looks like it should be 21 to 9, but could it also be 7 to 3 because I have 7 boxes and I have 3 boxes? And then I have my problem from the last one of this 14 to 6. Could it also be 14 to 6? Well, let's keep going. We just explored 3 different lengths, 21 feet, 14 meters, and 7 inches. Did our tape diagram ever change though? Please answer that question on Socrative. Did our tape diagram ever change? Please answer that question on Socrative, then wait. Okay, 10 more seconds. Alright, the correct answer was no. I still had the same picture for every tape diagram. So let's think, what did all of the ratios that we wrote have in common? Well, if you remember back at our I can statement that should be in your notes, we should know that they are all equivalent. They were all equal. They all had that same picture, that same model, and every single time the model was equal to the previous model. We use models to show math understanding. If our pictures are the same, that means the math problems were the same. Okay, what you're going to do in your notes is you're going to copy our models down. So here we have Karina's and Japsiri's, and I want you to copy this down, this whole first part. Karina and Japsiri, and we're going to say each one is 1 inch. So I have 1 inch, 2 inch, 3 inch, 4 inch, 5 inch, 6 inch, 7 inch. 1, 2, 3 inches for Japsiri. You're also going to copy this part down and the bottom part down as well. What would it look like when they were 2 meters? 2, 4, 6, 8, 10, 12, 14. 2 Japsiri's 6 meters. Then our third one is, what if it was 3 inches long? We'd have 3, 6, 9, 12, 15, 18, 21. You have till the timer goes out. If your notes aren't finished today, then we will finish them at lunch tomorrow. Please copy all of those models down. You have till the timer is done. We're just showing how our models are the same even though each box represents a different number. It can represent 1 inch, 2 meters, 3 inches, but our models are all still the same. Okay, you have 30 more seconds. You're copying everything down on this page into your notes. All right, pencils down, eyes up at the active board. Okay, so we're going to try one more. We're going to go much faster on this one. Ernan and Eric ran laps to train for soccer. The ratio of the number of laps Ernan ran to the number of laps Eric ran was 2 to 3. If Ernan ran 4 miles, how far did Ernan run? Draw, so that keyword here, draw. Tape diagram to demonstrate how you found the answer. Well, I know Ernan ran 4 miles, but I don't know how far Eric ran. But I know it's a ratio of 2 to 3. So I start out with drawing my ratios. Here's my 2, there's my 3, and it's telling me that Ernan ran 4 miles. Well, if I have 2 squares and he ran 4 miles, that means my first square is 2, my second square is 2. And now I'm going to ask, well, how far did Eric run? Well, this square is the same length as the square for Eric, so it's going to be 2 also. All my squares are the same length, so each square is 2. So here Eric ran 2, 4, 6. So Eric ran actually 6 miles. Good job, Eric. Now I have this problem. What if Eric ran 930 meters? How far did Ernan run? Draw a tape diagram to show your understanding. Well, here I have this problem. I have this big number, 930 for Eric. How big is each square? I don't know. What I do know is I do have 3 squares, and when I am making equal groups, I'm dividing. So this would be 930 divided by 3, and that'll tell me how big each square is since they're all equal groups. 3, 1, and 0. So my answer is 310 for this square. How far did Ernan run? Well, it's the same size. This square is the same size as this square, so 310, 310. There's my 310. Here's my 930. Ernan ran 310 plus 310. So Ernan ran 620 meters. Good job, Ernan. Okay, with a partner, you're going to solve this problem. Daniel took a multiple choice end of the year vocabulary test. The ratio of the number of problems Daniel got incorrect to the number of problems he got correct was 2 to 9. What I want you to do is I want you to solve this problem with a partner. Alright, if you are the teacher in the room, will you pause the screen? On YouTube so that they may copy this down and they may solve it. When the class is done, I'm going to have you go on to our solutions. So here's our solution for the first one. Daniel has a ratio of 2 to 9. So Daniel had 8 incorrect. So how big is each section? Well, each section would be 4. So here I would have 4 times 9, since there's 9 boxes, which is 36. So Daniel would have got 36 questions right. Number 2, he missed 20 questions. So that means each box is 10 for his incorrect. 10 plus 10 equals 20. And all these boxes down here are 10 each. So that would be 10 times 9. Daniel got 90 correct for part B. Part C, what ratios can we say are equivalent? Well, I just showed that 8 to 36 was the same using the tape diagram, and 20 to 90 was the same using the tape diagram. So these are my equivalent or equal ratios for 2 to 9. Okay, your lesson summary. Ratios are equivalent if there is a positive number that can be multiplied by both quantities in one ratio to equal the corresponding quantities in the second. All that's saying is when I have a ratio, so here I'm going to say I have 5 to 2, and we're going to say it's just boys to girls. Whatever I do to the left side, whatever I multiply my left side by, if I multiply it by 3, so 5 times 3 is 15, I have to do the same thing to the right side. Multiply it by 3, so 6. So it's the same thing as equations. Whatever you do to the left, you have to do to the right. Whatever you do to the right, you have to do to the left. But I drew that backwards. Whatever you do to the right, you have to do to the left. Okay, you guys may play Ratio Rumble until the end of the lesson. Alright, I hope you're wonderful. See you tomorrow.